Well, I mean, I'm not going to do it every time. Okay, so this chapter is on power. And obviously all this stuff is related to power as it relates to the personal computer, right? So let's start from the beginning. Wall outlet power. Okay, we have wall power that is transmitted from outer space to our wall outlet, right?
Yeah.
Okay. What kind of power is transmitted to us?
AC.
AC power, right? So AC power comes in because it's the most efficient way to transmit. AC is alternating current, and it alternates at a frequency of 60 hertz, which means 60 cycles per second. It alternates. But alternating power is crappy for electrical components. In fact, airplanes are the only place I've ever had AC power an electrical component. Everywhere else it's usually DC power, and DC stands for
Direct current.
okay. DC is direct current. It's level at some voltage, okay? And when it comes to PCs, we have AC in from the wall, we have a power supply in the middle, and then we have DC coming out, okay? So the power supply acts as a what? Do you remember what those two terms are?
Power conversion.
Okay. Works as a transformer and a rectifier. Okay, it works as both those things. It rectifies AC to DC, and it transforms 115 to 3.3, 5, and 12 volts. Okay. A transformer that you see, think of it this way, transformer out by your house is taking big high voltage power lines and turning them in. It transforms that power down to what we get at our house. Okay, that's a way to remember transformers, right? You see transformers everywhere. They don't change AC to anything other than lower voltage AC. A rectifier changes AC to DC, okay? So our power supplies are transformer rectifiers. They do both things. They rectify it to DC, and they transform it to the voltages that we have in our PC. Okay? So we've got DC power from our power supply unit. By the way, that's what PSU stands for. If you ever see PSU, it's power supply unit. Okay? And we've got different plugs coming out, and we need to be able to identify the voltages that apply to those plugs. Okay? We've got a big, huge one. It says P1 on it, no matter which one we have. And that either has 20 or 24 pins on it. What does that plug into?
Motherboard.
Plugs into the motherboard, right? I have to verify that I'm recording. How fast I am. Good. Okay, it plugs into the motherboard. What's the voltage on that one?
3.3.
3.3 volts. Okay? And then I've got all the other ones that are four connectors on there, and they can be the Molex ones, or they can be the SATA plugs, and that includes the P4 plug to the motherboard. All those are what voltage? 12 volts, okay? They make big things happen. It's the highest voltage. We got hard drives that spin up to 15,000 revolutions per minute. That's really, really fast. That requires higher voltage, okay? And then we got the one that goes to the floppy drive connector, okay, and that was 5 volts. Okay, so those are our voltages. I guarantee on the test that we're going to have a picture that looks like, there we go, there's the my content, chapter 3, power, that's where I want to be. I wish I could shortcut it to there, I can't. So we'll have something like this that says something like, of course it's the wrong one when I do it, Control Z and Control Z because I want to do that. There we go. Okay, So it's going to have something like this, that it has A, B, and C, and you have to match the power to the plug. Okay? I could also have A, B, and C, and it has motherboard, hard drive, floppy drive. Okay? And you have to match the plug. Do you guys think you can do that?
Yeah.
Okay. Okay, so while we're talking power, let's talk our power terms, okay, that we also need to be able to understand. And those are volts, amps, and watts. Those terms we need to be able to understand for this. Okay, there's also a fourth one called ohms, which I said I don't test over because it doesn't really apply to our ability to select a power supply. And since this class is about PC stuff, why am I introducing something? Okay, ohms is resistance. We don't care about that one. But I just want to say that that other term does exist. It is just isn't one that we use to talk about PC power supplies. Okay, so volts. What are volts?
The potential amount of energy.
Okay, and I did an analogy with volts and what? What did I say? It's like.
Water pipe.
Okay, it's just like the size of a hose or the size of the pipe. Okay, the bigger the pipe, the more potential for more water to come through it. It doesn't mean there is. Okay, so volts is the potential of an electrical circuit, like the size of a pipe, whereas amps are
Actual current.
the actual current going through the circuit. C-U-R-R-R-C, no, that's the U, there it goes. Current, okay, going through the circuit, it's the flow of electricity, okay? So if I have a certain potential, and then I have a given flow, if the flow is the same on this little one, we'll label it 1, and the flow is the same on 2, which one's going to have more power going through it? 2, the one with more potential, okay? Because if the flow is the same, but the potential is higher, then the bigger potential one's going to end up with a higher total amount of power, which is why watts equals
Volts times amps.
volts times amps, okay? It is the flow multiplied by the potential that can go through there that equals the total amount of power, okay? Total power. And all this should be in your notes. So if it's not in your notes, transcribe now, transcribe later, but make sure this information is in your notes. So let's apply that. The application of that is when we're looking at all those plugs that are on our PC, okay? And we say we've got a hard drive pulling 2 amps. How much power is that hard drive pulling?
Just 2 watts. 4 watts.
What does watts equal?
Volts times amps.
Volts times amps, okay? Have I given you one of those numbers? I gave you 2, so it's volts times, it's not, times 2. What's the voltage? I said it's a hard drive.
It's not a hard drive.
Oh wait, yeah, that was
12.
12! Well, there's our application, so it'd be 12 times 2, which equals 24 watts. Okay? So that hard drive, if I say it's pulling 2 amps, it needs 24 watts of power. So when I'm adding together all those power supply component parts of my PC, this particular hard drive is holding 24. So in my application of my knowledge here, if I just told you the amperage of your components, you should be able to figure out how big the wattage the power supply is. In other words, let's do this one. Okay, I'm going to give you the amperage. We've got a floppy drive, okay, and it's pulling 1 amp. And I've got a hard drive, it's pulling 2 amps. But I've got 3 of those hard drives in there because this is a server, okay? I got a motherboard that's pulling 4 amps. I got a CPU that's pulling 10 amps. Okay, I've got a CD-ROM that's pulling 2 amps. I've got memory times 2 sticks, each pulling 2 amps. Okay? What did I forget? I got a video card in there that's pulling 5 amps. And I got USBs times 2, each pulling 1 amp. What is the recommended PSU wattage? Figure it out. I'm pausing. Okay, during this time, you should do all this math. Please pause the video at this point, do the math, and then before continuing. Pause here. Because we're gonna, okay. So, why did I change the amperage, by the way?
Because
I wasn't thinking, what's the voltage on that?
voltage on a motherboard would be 3.2.
Yeah, do you think it's only pulling 12 amps or 12 watts? No, that would, I mean, like, I walked out and I go, oh, wait a second, I didn't get, okay, these are all made up numbers, obviously. I just made them up off the top of my head trying to estimate, but I wasn't estimating right because I wasn't thinking 3.3. So let's add all these things together. I'm going to go and let's see if it'll let me grab them. And then I'm going to group them so that I can then shrink them down. Look at that. That was like magic. Woohoo! Okay, so I'm going to lock that up so we can go ahead and do this math here. I'll pick another color. We'll go to black. The floppy drive. Let's go through the components. Floppy drive's pulling how many watts?
5.
Okay, 5, because 1 times 5 is 5. Our hard drives are pulling how many watts?
36.
Okay, so we got 3, so 6 times 12. There's 3 of them. They're each pulling 2, so that's 3 times 2 is 6 times 12. 6 times 12 is...
12. Oh my gosh.
Oh man, I just got the problem wrong, Mr. Bull! Ah! Okay, so you said 36 because you did 3 times 12, but they were actually pulling 2 amps, right? So my hard drives, it's really 2 times 12, and there's 3 of them, right? So it's 3 times 24.
It's 72.
Which is 72. I'm waiting for you to do my math for me. Okay, so it's 72. Man, you gotta pay attention. Mr. Pool's gonna trick you, and he's not even trying to trick you. Okay, our motherboard now is how many watts?
145.
Okay, 145. Let's see, 44 times 3.3, is that 145? That can't be 145 because 3 times 4 is 12.
No, it's
145.2.
Okay, we'll go with that. Okay, so our motherboard is 145. I have a hard time not saying 146 because I kind of think we should round up with that, but you know we're putting error in there anyway. So CPU, what's it pulling? What? What? Didn't this math done yet? Why isn't it written down?
Because I thought you were saying that's the total. I thought you were saying 30 was the.
Okay, so 30 times 3.3 is
99.
okay. So we'll say 100 because 99.9, right? So 100. I did that math in my head. Oh no! Okay, so we're gonna say 100. What kind of CPU is it? Based on my other charts that I did that you've done before, what kind of CPU do you think it is?
Double core.
What? What?
Dual core.
What?
Quad.
Quad core, you're right. Yeah, good guess. Quad core, yeah, because it was 50, 75, 100. 75 was a dual core. Okay, so it's probably a quad core server, right?
Yeah.
And then our memory, we got 2 sticks of RAM at 2 amps each. So how much is our memory?
30.
What? How much
memory full?
I don't know, where's it pulling it from?
Memory.
It's 6.6.
Okay, it's 6.6, which is really low, right?
Yeah.
I should have come up with the number. But it's 6.6, and because we're rounders here, we're going to say that's equal to 7. Okay, video card. 5 times, video card has its own power. Plugging in if it's times video card, so 5 times 12 equals 60 amps. Holy moly, Mr. Poole, I got this so wrong, it's crazy. USB?
6.
Okay, how do we get 6?
2 times 3.
What?
2 times 3.
Where do we get 3 from?
I don't know.
Oh, 3.3. Okay, because it's going through the motherboard. Sure, I'll go with that. Because that's what I wondered, right? We had USB from our chart was 3 anyway, right?
Yeah.
Okay, so we're saying 6. Well, we'll call it 6 down there. Okay, so what does that add up to?
Well, it's on the tip of my tongue.
I'm just
On the
reminding
tip
myself.
of my tongue. I was reminding myself, I need to do this better next time.
You know,
I'm checking my answer.
I'm just triple checking. I got my my calculator calculated as 395, and my minimum would be like 400, and then like recommended is 450, and
Okay,
then
and I asked for recommended, so the answer is
450.
450. Okay, which means
How did you do that?
my recommended should be 450. And on your question on the test, it's going to have 300, 350, 400, 450. It's going to have the right answer, and it's going to have the other answers on there too, so that if you don't actually pay attention to what is being asked, you will get it wrong. Because I know that you can add numbers together sometimes. We're going to have to do another one, aren't we? Or have we made the point? You've got to go through and say, where's it pulling the power from? Because that's what I did wrong here. Where's it pulling the power from? Video is pulling it from the PSU. So if it's a good video card, it's got its own power supply plugged in. And I guess I could really give a thing on there that says this is a high-end video card with its own power source. Because not all video cards do, right? This video card is a low-end video card. It has no extra power connector. It's pulling its amperage directly from the motherboard. Wattage of the voltage of the motherboard is 3.3. So, okay. So this is just an example of, you have to look at the amperage, you have to multiply it by the appropriate voltage, you have to add all the watts together to come up with that answer, okay? Now, I'm probably going to give you one of these and a link to something else, okay? I'm going to give you one of my voltage charts. One of my wattage charts, and I'm going to give you a link to a PC. And you're going to use a chart like this, okay? Because that's realistically how you're going to play it. There is no motherboard or no PC out there on the web that you can go find the thing, and it's going to show you the amperage of the components. It's just going to give you the list of components. So I really want you to be able to take, this is an application of the math and the understanding the wattage, but this is an application of realism. That if I give you a link to a PC out there and I say, what is the efficient power supply rating, wattage for this PC, then you'd have to go and you have to use the chart, and you have to add stuff together, and you come up with the calculated minimum recommended efficient. And remember, anything over that still fits into it, okay? So when you do your math and you come up with a recommended of 400 watts, and I give you then a power supply link, which I will, and I will say, does this meet your recommended power supply? As long as it's 400 or more, the answer is yes. If I give you a link to something that's 750 watts, and I say, does this meet your recommended power supply? It's yes. It doesn't have to be that number. It has to be that number or more to meet that. Okay? Because just like I told you in class, you come up what you need with what you need. That doesn't mean you want to buy that. You want to buy the best cost base that meets that as a minimum. Okay? So if you found a 750 watter that was a better deal than a 400 watter, you wouldn't buy a 400 watt power supply. Or had better plugs. Okay, we looked at that online the other day too. We looked at a couple of power supplies. As we go to look at power supplies, we have to look at, does it have all the plugs I need? If it's got one floppy drive and a motherboard plug and 3 Molex and no SATAs, and I know my drives are SATAs, that's not a power supply for me. You need to get the one that has the plugs that you need, okay? But we need to be able to apply this information too, okay? You guys said that you could do that. Do you want me to give you a problem? I'm going to give you one to go to. You want to pull one up and you guys figure one out? Yeah, Mr. Ford, why do you do that? Okay, well that's a good idea. Thank you for saying that. Let's see. Let's go. Why did we open it? That's because I'm over here. We're going to open a new tab, and I'm going to pull up our chart because this one really is a. That's the rubric. That's not. Okay, let's find it again. Our wattage worksheet. There we go. We're going to use these numbers because I like these numbers. And that's not what I wanted to do at all. Let's see if I can zoom in a little bit. There we go. Screen. Go over here. I'm going to pull up a new one. I'm going to paste. I want to cut this. Can I cut this in? I'm going to start. Okay, so we're going to use this one right here, and I'm going to go find us a PC. Let's go find a PC. I'm going to do it on the fly here. And we're going to go find the wattage for a particular PC. Let's go to Newegg and find ourselves a nice gamer PC. I can't go to that. I hate when I can't go. Oh, no. Let's see. We're going to start all over again. Computer hardware, PCs and laptops. Go to desktop PCs and see if it lets us pick gaming entertainment. There we go. And let's pick this one for $1,000 right here. We got some money. I'm going to go over here because I like the look of that one. Pick one of these 3. Which one do we like the look of? I'm going to go with the CyberPower Gamer Ultra 2166. Okay, so this is the one I want you to use, and I'm going to throw that link right on Moodle right now, right down here, but I'll put it up top. Switch roll to terminating on, and I'm just going to add the link right up top, link to, so that if you guys refresh your page, wait, we want a new window, save. So you're going to have that link right up top right there. If you click on that link, you're going to go to that Newegg site. I want you to go, and I want you to use this one, and I want to know the minimum efficient power supply. Okay, minimum. Okay, so if you're watching it right now, pause right here and do the problem for this PC using the numbers on the worksheet that's also linked on Moodle. Using the numbers from the worksheet, the link is right up top right now. It says Newegg blah blah blah. I click on there. Using the numbers in the wattage worksheet here, calculate the one right now for this PC. Like that. You don't get humor like that every day. So, do we have a motherboard?
Yeah.
Okay, so we got a motherboard. And I didn't lock that, so let's see, Control K, Control K. Now I need to move my check, because we said it's octa-core. There we go, now we're back on here. We got a motherboard. Next one is video card. Now I'm going to assume it's a gamer, but let's go look and see how good of a gamer video card we got, because there could be 2, right? Let's see, let's go to specifications. Motherboard CPU graphics. an AMD Radeon HD 7770 1 gigabit. Okay, so it's got 1 gig of RAM, but it's just a single video, or a single gamer video card, right? Yes?
Yeah.
Okay. How many sticks of RAM?
2.
Okay, so it's got 2 4 gig sticks of RAM to give us our 8 gig, and I just saw that when I scrolled by. There's no reason to look at it. Optical drive?
1.
Only got 1. Here we are. Okay, let's see. Spec CPU. I'm gonna look at the CPU specs here just because. It's really nice. 3.5 gigahertz. Octa-core PC. I almost want to buy this right now.
Turns out it's discontinued.
You should buy it.
Oh, is
in
it
Vermont.
discontinued?
No, but like right as
You
you
should
buy it.
buy it immediately.
Because this would really make a good, I mean, I wouldn't use that case. It would make a really good virtual server for Trail 4 that we're looking about doing right now. Ooh, and then I could use the keyboard and mouse for me.
You can give us the keyboard.
That's pretty cool.
You
I
can
like that
give me
keyboard and
the
mouse.
Keyboard, he can have the mouse.
Let's take a look at the inside. How many cooling fans we got?
There's one.
Just this one right here. This is a bottom mounted power supply like the one I have in my computer at home. Let's see, back. Let's look at the back. We've got, there's our video card, and it's a double slot video card. It's a big honker there. It does have integrated video, but this is going to override that one. 6 USBs on the front. It still has PS2s. Oh, those are for cables to come out, I think. It's, you know, the thing is, okay, yeah, it's kind of cool mouse, but it's still wired. Why would you not put a wireless mouse on a gamer? That just bothers me. Oh, it's a big clear one.
What's wrong
Okay.
with wired mouses for gaming?
What?
What's wrong with wired mouses for
I
gaming?
just don't like wireless for anything. Or wired mouse for anything. If I'm gaming, man, I don't want the wire in my way. If I'm moving my hand around, the wire gets caught up on there. I want nothing but room on my desk when I'm gaming. It's a very, I will tell you that the downside of what I see of this system right now, if I was buying the system, is right there. That is a very small, generic CPU heatsink. It's the stock AMD one that's coming with that octa-core CPU, and that would be the one thing that I would want to replace on this system. Now you'd have to see my cooling fan at home. Mine, I've got a big, huge monster cooling fan. It's like this big at home. In fact, let me see. Let's get back to our problem. So we got our optical drive. How many hard drives?
One.
How big is it?
It's 2 terabyte.
2 terabyte hard drive. Hard drives. 2 terabytes, SATA 3, 7200 RPM. There's our other one. Oh, this is good. This is our information right here. It's got a 350 watt power supply. How do we feel about that?
Not bad.
How many floppy drives? None. No other expansion cards. USB that it's using, I'm going to say 2, right?
It's got 2 in the front and 6 in the back.
Yeah, but how many per used device?
So it'd be like for keyboard and mouse?
Keyboard and mouse, yeah. Extra cooling fans 1, so let's do our math with our calculator. We got 50 plus 150 plus 120 plus 30 plus 30 plus 25 plus 6 plus 3 equals 414 is what I got calculated. Is that basically what you guys got a little higher because you included all the USBs, which is fine, but this chart says per used device, not per USB available. Those are the 2 different options in my recording. Those are the 2 different options there that you would see on my chart. Either I want to know what's being used, which is the least conservative, or per available, that's the most conservative, meaning that if you had everything plugged in, that's how much power will be full. Okay? Just so you know the 2 options, make sure you read that. So if I got 414 here, that's our calculated, our minimum is
450.
450, our recommended is 500, Our efficient is
500.
550, and I just said which one? In the original question, I asked for you the
Or
efficient.
you asked for the efficient.
I asked for the efficient, which means I'd like to have a 550 watt power supply. If I buy one that's efficient, I know that I can expand. I could add a second gamer video card here. I'd still be fine, right? Next thing, we're talking about a gamer CPU. You would not want to go with this one. If you went with this one and added a gamer video card and it was pulling another 120 amps, we're dead, right? Right away, we're done. Even if I went up to here, if I added 120 here, that's 534, I'm over recommended. If I add, because I'm talking about a gamer one. Whereas if I got an efficient one, I'm still okay. It's still not going to burn up. So that's where I would shoot for if I was a gamer. Especially because a gamer one's going to use more power. You're going to use your CPU at a higher rate. It's going to, so I want to be more efficient, okay? And this one only had a 350 watt Zowie Batman. Okay, now realize, this is all conservative, right? When we went to the online chart, we came up with much lower number because it's using the exact power that that hard drive uses and that optical drive and that video card and, so it's more conservative because I really don't know what this AMD Radeon HD 7770 pulls. I could probably safely assume that they figured it out and that meets the minimum. But that's all I think it probably meets. Okay? I think that's our low end of this system right there. We got a cool, now is it still worth the money? I'm going to say it's still worth the money. For a octa-core CPU with 8 gig of RAM, now what would really throw it over the edge for me, that I would say I'd buy it today, is if it didn't use both the memory slots. If it had 4 slots and it was using 2, that would be awesome. Okay? But it's got 2 slots and it's using 2. Nah, expansion of 0, right? I can. It says maximum memory support is 16 gigs, so I can put 8 gig sticks in there. How much is it going to cost me to make this system all it can be if I really wanted to do that, okay? So let's go ahead and go to figure that out while we're here. If I wanted to get this all the way up, I'm going to go to memory, and what kind of memory did it take? It took memory, it takes DDR3, okay? So I'm going to go to my desktop memory, and I'm going to go to DDR3 right there, and then I'm going to say I want capacity show more. I want 16 gig, 2 8 gigs right there, and I'm looking at some change right there. Let's see, I'm going to go by lowest price. The lowest price I can do that 16 gig for is $120, $118.99. Okay, so $118.99 is the cheapest I can go to upgrade my memory. And that's the point between, if that was where I had 2 more slots and I only wanted to buy 2 more 4 gigs, how much would that be if I didn't have to throw that old memory away? Let's see. I'm going to go, where's my little link? I'm going to undo that one. I'm going to go back and say instead, what if I wanted 8 gig 2x4 to get to that same 16 gig? Now I'm looking at $64, half the price. Okay, and that's what that cost me by getting a motherboard that only had 2 slots. Now I might be happy with that altogether. Okay, I might be perfectly happy with having just 8 gig of RAM, and if I am, then the only other thing that's going to burn me eventually is going to be that power supply, and I'm going to want a more efficient power supply.
If I can now have the second group of Renaissance members that will be working with Pinterest, please come down to the office at this time. Thank you.
I'm not slamming this price for what you're getting. You're getting a nice PC for your price. You're going to get a cool case. That's a pretty good deal right there. Okay, just as I'm looking forward, if I wanted to buy more RAM, I definitely am not going to put 16 gig of RAM in there with that 350 watt power supply. I think you're really going to be pushing it. So if I wanted to make this the perfect machine for me, I want the 16 gig. I want a better CPU fan, and I want a better power supply. That is not efficient power supply at 350 watts for this. and it probably doesn't have any information about our power supply down here anywhere, I would bet. No, nothing. Other than the 350 watts, because it didn't want to tell us, oh, by the way, this one's kind of sucky. Okay, it's not going to tell us that. Okay, so let's finish as quickly as we can our other ICANN statements before they call us down. We got the volts, amps, watts. We got the DC versus AC. We got with DC voltages. We didn't talk about hot, neutral, and ground. We did that in class. Any questions on that? Are you in band or something?
Yeah.
You're not going anywhere. Okay. We didn't talk about static electricity. We should know those voltages for feel it, hear it, see it. They are what?
3,000, 6,000, 8,000.
3,000, 6,000, 8,000. If I discharge 2,900, 2,900 volts into a motherboard, will I even know it?
And you do what?
If I discharge 2,900 volts into a motherboard when I'm touching it, will I even know it? No, I won't even know it. The point of that is, you won't know it, but you could easily ruin components. Oh, we didn't talk about brownouts, blackouts, voltage spikes, and upses and power conditioners and surge protectors. If you don't remember that stuff because we're running out of time, why is it this early? You've got a half an hour left. There's a half an hour left in my class.
Is that for practice?
Okay, you go to your thing, but we're going to go over that right now because we aren't out of time. We still got a half an hour left. Me and Mr. Hill will go through that. You might want to watch the end of the video. Okay, so we've just done our calculation thing, and we're going to go ahead and move past that. Okay, so we've got electricity. We're going to go through that talk right now. Here's our electricity, and it's coming through, and it's an even keel, and then all of a sudden the voltage drops down momentarily. What is that called?
Isn't that like a surge?
The voltage drops down momentarily, and that's called a brownout. What is the only device that will, what two devices will help us with the brownout?
Power conditioner
Okay.
or PSU.
Okay, that's going to be on the test, and it's not a PSU because that's a power supply unit. What, you mean a...
Oh, you.
The same initials, but they mean something else.
UPS.
Uninterruptible power source, okay? And ups and a power conditioner will both solve a brownout, okay? The only thing a power conditioner does is a brownout, okay? So when there's a matching question on there, and it's going to say, which one is the best one for each? Realizing that an up solves a brownout, it also solves every problem. The other ones don't, okay? So power conditioner is the one that is the best for a brownout, okay? So if my power is going along steady and it does, and it all of a sudden comes up and down, that's called a
surge.
Okay, or a spike, okay? A surge or a spike. Am I recording? Yes, I am. I know I keep checking that, but I want to make sure. Okay, so it's a surge or a spike. What two things help surges or spikes?
Power conditioner.
Nope.
No.
Nope.
Power suppressor. Yes. Power supply. I don't know. I forget the name of it. Surge. Suppressor.
Okay. This power strip, okay, absorbs surges and spikes. And the other thing that it will do that is also an ups. Okay, if we do that, does everything. Okay, surge suppressors are really inexpensive. Okay, these are the least expensive one, and all your electrical equipment should be in those. Because all these spikes, you get little spikes and surges all the time on your devices, and eventually it will burn out your power supply. But if you have a surge suppressor, it won't. Okay? So the last one is, if I've gone along with power and all of a sudden, it's gone. There's no power. That is a blackout. And the only device that will help in a blackout is a ups, or an uninterruptible power source, because it has a big, heavy battery in it. Okay? So when I'm matching those things, blackout, the best thing, you can only match each thing once. So a blackout goes to ups, a spike goes to a surge suppressor, and a brownout goes to a power conditioner, realizing that an ups actually does all three. Okay? So that's the gotcha on there. Let's go back to our ICANN statements. So that's the best devices for each one. Explain the difference between a power strip, surge suppressor, and an ups. What does a power strip do?
It just lets you add multiple devices into it.
It just lets you plug stuff in. That's all a power strip does. A power strip does nothing to the power. It just goes and spreads it out. Okay? A surge suppressor does that, but it also has an electrical component in here that stops surges. It has what's called clamping voltage. I can touch every single button until I get the right line. Okay, so a surge suppressor has some clamping voltage associated with it that as long as the voltage is below that, it can go back and knock it off, and it just goes to ground. And that spike goes to ground. So when it goes like this, what happens is that spike goes to ground to level off the power. Okay? So the higher that clamping voltage number, the better the surge suppressor is. Any surge suppressor is better than a power strip. Doesn't matter what it is, it's better than a power strip. Okay? Because a power strip does none of that. It doesn't do anything to help your power out at all. It just spreads it out. Okay? So the difference between your battery, just did that. Calculate and understand the wattage for a power supply based on the components that you're installing, and I already did that. Okay, we just did that today. Test a power supply we did in class, replace and install power supplies. We did in class. Second block, we recorded it for a student that was missing, and if, for some reason you're like, I don't remember how we did that, that's on the video right here. We actually took a picture of Mr. Poole taking out the power supplies on the video there. And I'm going to go back and remind everyone that's watching this that all the lessons that we've done for this whole section on Chapter 3, I don't have all of ones from Chapter 1 on there, all of them are in here in the class calendar. Okay, all of them. So that's it. That's the complete. Got through all the ICANN statements. Okay, for this section. Oh, I went here and then I came off. Okay, so we went through all the ICANN statements on this section, and we should be ready for the test on Tuesday. Questions?
No.
No questions. Okay, I'm gonna stop the video right there. Ching. Save.